Hi, everybody. My name is Jim Graham. I'm up in Humboldt State University in beautiful Arcata, California, and I'll be talking about CanvasMap, which is an open source library for creating online maps. I've been building it for about 10 years. Okay, a little bit of background. If you've done web development before, this will be old hat. HTML is hypertext markup language. It's the language that almost all documents of the web are created with. CSS, or cascading style sheets, provides the control over colors, fonts, line widths within HTML documents. And then JavaScript is the only programming language that's widely supported on web browsers now. And it provides a lot of the interactive capability and the animations that we love so much on the web. All right, there's some recent changes that are really exciting on the web, and I have recent in quotes because these were so big. We are still figuring out what to do with them and still getting toolkits that are helping us to work with these technologies. HTML5 was a huge release of new different types of elements for HTML pages, including a canvas object, which is what CanvasMap is named after, for pixel level editing. OpenGL is a 3D programming interface, allows to do 3D models inside of the web. And then SVG, or scalable vector graphics, allows us to do smooth, high resolution vector drawings at any resolution. So the goals for CanvasMap were to create a library that would support a large variety of online maps, including 2 or 3D maps, support any projection, not just Web Mercator, minimize the cost of implementation and support. In other words, make it easy to put up online maps. It should be supported on desktop and mobile platforms, relatively easy to use for spatial developers. In other words, folks that aren't necessarily web developers, but are GIS folks or other folks working with spatial data. Wanted to make it extensible so people could expand it to do pretty much whatever they wanted. And I didn't support all of the available data standards because there's a lot and some of them have performance issues. And I didn't support all types of maps. Instead, again, focused on the extensibility of the library. So CanvasMap is open source. It's available at canvasmap.org, and it's there to put maps on the web. It's based on object-oriented design and programming. So it's very expandable based on JavaScript classes. It uses a number of open source libraries and standards that I'll mention. And then again, it's based on standards for JavaScript, HTML, and CSS. It's been in development for over 10 years, and I've used it largely in my classes, which is just a great place to develop a library, because nothing like having a bunch of students to criticize your work and give you ideas on how to improve things. So as I said, a bunch of open source libraries, w3.css, which I found really easy to learn and use, put up beautiful web pages. 3.js is the OpenGL or 3D library that I use. Google Fonts and Material Icons for fonts and icons. Turf is a library for geospatial analysis on the web, and I used it for clipping projected areas. SPA is a JavaScript-based library that I created that includes a bunch of web utilities, geometries, Bezier curves, etc. And then there is a Python server element, especially for doing projections. And it's based on SpaPy, which is a geospatial library created by myself and my students, which also includes a bunch of the standard geospatial libraries, Prod, Shapely, GDAL, Ogre, etc. All right, it does support, or CanvasMap supports all the major browsers, Chrome, Edge, Safari, Firefox, on Windows, Mac, Linux. It does support desktops, tablets, and cell phones. Cell phones were quite a challenge, and over on the right, you're seeing a recent project we worked on. It's a Eureka art map, and it runs really nicely on cell phones, and this is the design of the interface for it. It does use common standard data formats like GeoJSON and PNG and JPEG. TIFF is not supported on the web. Really, we just have PNG and JPEG. And then OpenStreetMap or Slippy tiles. So here's an example I'm just going to go to in a browser and show you some of the capabilities. This looks like a fairly typical map initially, but this is actually a UAV image that we took at one of our research sites, Levy Ranch here in Arcata. And you can see that it's using tiles, both from OpenStreetMap and also a custom solution for doing raster and vector tiles. The really fun part of this is you can go in and then you can see all kinds of different layers, land cover, soils, water resources, but also imagery and digitized gravel beds and stream layers from different decades based on different aerial photography that was available. And so this is also showing the structure for the CanvasMap graphical user interface, where you can click, control the layers that are displayed. There's also different background layers that you can use, changing those out again with the Slippy tiles from OpenStreetMap. And there's also a search feature. And these panels are what allow us to support all the different platforms. And this is also one of the great ways to extend CanvasMap's capabilities. The design of CanvasMap is based on a main container. It contains all of the things you just saw. And then within the map, there's a scene. A scene can have multiple geoses in it. Each geos can have a different projection. So you can actually have multiple maps within a single scene. And then there's our familiar GIS layers within each geos. And there are foreground layers and background layers. And then each scene can have multiple views into the scene. There's also map items like scale bars and north arrows that I'll show you. And the layers are linked to data sets. So the data sets can be shared across multiple layers to reduce the memory footprint. And then we have the panels. A lot of features, like I mentioned, the panels, foreground, background search, help, other ones. That's one of the areas I've found it really easy to extend CanvasMap when folks are looking for unique features in the graphical interface. Map elements, I'll show you in a second. There's tools, and you can add tools. It's another area of extensibility, different types of layers, both vector and raster, of course, and then different items. It comes with a full drawing environment, so you can create rectangles, ovals, icons, polylines, etc. And then text, including curved or straight baselines. And again, the 3 different data sets it currently supports: GeoJSON, OpenTiles, and then Blue Spray tiles, which are raster and vector tiles combined into one. Here's another example showing those capabilities for Humboldt County. So there's good old Humboldt County, Northern California. If we zoom out, you'll see this is actually UTM projection. And as we zoom in, we've got graticules. We've got a north arrow that moves with the map. And then we've got a scale bar down here, which is actually accurate to the location that it's in that corner of the map. As we zoom in, you can see this is tiled, both raster and vector. And you can see the roads for Humboldt County loading in progressively as we zoom in closer and closer until you have every single road in Humboldt County, but still with good drawing speed. Okay. Oh, and in development is a layer for and data set for Postgres and PostGIS, and the graphical editor is pretty much ready for release. Okay, one of the areas that took a lot of work was projection support. I've created a whole nother website. The link is there in the presentation. And what I did was supported Proj on the server and then created a web service that connects it with the website, and it supports all of the Proj library projections, which is the largest assortment of projections available anywhere that I know of. Oops. There's also an Explorer. This is actually based on CanvasMap, where you can go in and you can take a look at the different projections. It takes a little while to load. And when it's up and running, we can take a look at all the different projections supported by Proj. And we can even run this just for fun. Okay, so the 3D part. One of the goals I had was to see if I could build a library that did both 2D and 3D. There were a fair number of similarities, but most of it was around management of the data and the graphical interface. So the main container, the panels, data sets, projectors, most of the data management and the graphical interface. The differences ended up being pretty large because cameras, controls, and lights are all part of doing 3D work. It's not just adding a third dimension. You've got different cameras at different angles. different ways of controlling the view and flying through a scene, lights, and then textures on surfaces. We had new data types with terrain from DEMS, bump maps to change how the terrain is viewed, and then new items, boxes, spheres, cones, all kinds of things. And symbology for spatial data, which I think is really a whole new area of research, looking at how do we symbolize spatial data in a 3D environment. Okay, and I'm going to go back to the website, kind of bounce between them here. CanvasMap.org, and go to the 3D examples. And here's one for Hawaii, and you can see the data load in. It's a fairly large data set, and then we can zoom in, pan around the Hawaiian Islands. There's a road layer that's overlaid on the DEM, and then the major cities in Hawaii. This is one of my favorites. This is actually two 3D scenes combined together, sorry, two 3D geos inside of one scene. This is Mount St. Helens just before the eruption. They captured 30-meter elevation data and a satellite image of it. And then, of course, more modern data showing what happened before and after the blast. And I added this little tool to be able to show the difference in the volume that occurred when Mount St. Helens blew. So just an example of how 3D could be used to visualize natural resource issues. This is one I'm working on for viewing Humboldt County, the coastline of Humboldt County in 3D. And pretty neat because we can change the lighting as well as topographic characteristics and how they're viewed. We can also do spherical work. This one's almost done. This is actually OpenStreetMap slippy tiles displayed on top of a sphere where you can zoom in and out, see the tiles loaded, and you can see it uses the same graphical interface, a lot of the same data management software, so fairly high level of reuse inside of a 3D environment. Let's see, there is a 3D editor in the works. This is it. This is just sort of my playground to try different things. You can see we can move simple objects around. We can move lights around. We can add different types of objects. This is an origin, so I know which way is X, Y, and Z. And these are actually Bezier curves that are supported with an extrusion. So pretty great assortment of objects we can work with in 3D. This is actually an HTML object, the USA. You can see that it follows the camera to display labels. I'm just going to mention that you can do graticules in 3D with text on them, but you're going to notice that this takes quite a while to load. To do high resolution, high quality text in 3D is a real challenge because it takes so many triangles or faces in the 3D world. It takes quite a while to load, and that's mostly loading the text here for the graticules. Does work, just takes a while. All right, so to use CanvasMap, you can just go to canvasmap.org. You can use it standalone on a web page, as most of the examples that you've seen did. You can then link it to informational pages. That's what I tend to do, is then link it to a WordPress site. But you can also put it inside of another HTML element. The panels can be hidden, so you don't have to see these if you don't want to. You can just put up a simple map, and then you can make it dynamic or static, so the user can interact with it as I was, or it can just be sitting there. Also, we've done a few where we put an iframe into WordPress and inserted a map into it. So the next steps for it to be finished up is to beta test the 2D editor extension. That'll be out by the end of the year, and then complete the 3D version and the 3D editor. Again, performance with large spatial data sets is the big issue there, and refining the cartography on spatial data sets. And I'll probably do that for certain data sets and then look to see what other folks do after I release it. Finish the Postgres, PostGIS data set, and then a new client-side projector. So I'm working on that a little further down the road. And globalization is something that I need to do. There isn't a lot of text in CanvasMap, but there is some for things like error messages. And just want to thank all of my students that helped me with this, especially Chris Mull and Brian Murphy, the other open source data developer or software developers, which I could not have done this without. Humboldt State ITS has been great in supporting this. And it started with work at Colorado State University with Greg Newman and Catherine Jarnovich. Feel free to contact me at jamesgraham.humboldt.edu and let me know if you have any questions.